So maybe you remember that with the law of sines, you could be given two sides and an angle, or you could be given two angles and a side. And either way, you could use the law of sines, but it worked out a little bit differently, so I made two different videos showing those two different cases. Kind of the same idea with the law of cosines. The law of cosines, you could either be given two sides and one angle, and you're like, wait a minute, that's the same as with the law of sines. Right, but with the law of sines, the angle could not be the included angle. So one of the cases of the law of cosines is if you have two sides and the angle in between those two sides, as pictured right here. It might be worth your time to convince yourself that if you had this information, you could not use the law of sines. The sine of this angle divided by this unknown side equals the sine of this unknown angle over this side. There's two unknowns, this side and this angle. Same idea if you try to use this angle, this angle, and this side. At any rate, this information is not conducive to the law of sines, but it works out perfectly for the law of cosines. Maybe you remember that the law of cosines, one version of it anyways, looks like this. So if we want to use this version of the law of cosines to solve this triangle below, well, the one angle we're given here, we want to make that capital C because the one angle in this formula is capital C. So if this is capital C, then this is little c over here, and I can call these A and B. If I call this B, then this has to be capital B, and if I call this A, then this has to be capital A. If these were already named for me, I could either rename them so that I can use this version of the formula, or I could just remember that there's really three versions of the law of cosines. This same thing, switching around the A's, the B's, and the C's. The way I remember it is just kind of change the letter that you have over here. So over here I have a little C squared, so let's make that little B squared. Well, if I used up the B on this side, then I wouldn't have an A squared and a B squared over here. I'd have an A squared and a C squared over here. And then I just have to remember the term in the middle. The term in the middle is always -2, and then this times this, so A times C, and then times the cosine of the capital of this letter, so B in this case. Similarly, if I started out with an A squared over on this side, B squared and C squared are what I would have left for the left side, and then I would have to remember to put in the -2BC for these two letters, cosine of A for this letter. At any rate, we'll use this formula. Playing the role of an A is a 4. Playing the role of B is a 6. So I got 4 squared plus 6 squared minus 2 times A again is equal to 4 and B is equal to 6 times the cosine of C, so the cosine of 60 degrees. And that's got to be equal to C squared. Well, let's see what this number is. 4 squared is 16. 6 squared is 36. The cosine of 60 degrees is 1/2. So 1/2 times this 2 just makes a 1, and 1 times 4 times 6 is just 24. So 16 plus 36 minus 24 has to be equal to C squared. Let's see, 36 minus 24 is 12. 16 plus 12 is 28. So 28 is equal to C squared. So C is either plus or minus the square root of 28. But because I'm talking about side lengths, it must be the positive value. C is just the square root of 28. Now I have all three side lengths, so all that's left to figure out are these remaining angles. To figure out angles A and B, I have options. I could use the law of cosines. Turns out you can use the law of cosines to figure out angles. I'm going to demonstrate that in the next video. But since we haven't seen that yet, let me show you how you could find these without the law of cosines. What would you do? Well, how about the law of sines? If I want to know capital A here, I could say the sine of capital A divided by little a, which is 4, would be equal to the sine of 60 degrees. 60 degrees being capital C, so I have to divide that by little c, the square root of 28. Note that I couldn't do that right off the bat because I wasn't given the square root of 28. That's something I solved for with the law of cosines. I can multiply the 4 over to this side of the equation and get that the sine of A is equal to 4 times the sine of 60 degrees divided by the square root of 28. The sine of 60 degrees is root 3 over 2, so I have 4 times root 3 over 2, and that's divided by the square root of 28. 28 is 4 times 7, so if you wanted to, this is optional, you could rewrite that as the square root of 4 times the square root of 7. And the reason you might want to do that is because the square root of 4 is just 2. So I could rewrite the denominator as 2 times the square root of 7, so that I don't end up with large numbers in the radical, so that if I want to rationalize the denominator, I don't end up with really big numbers. That's an optional step, though. This 4 and this 2 cancel out, and I'm left with 2 root 3 up in the numerator. How convenient. This 2 and this 2 can cancel, and I get the square root of 3 divided by the square root of 7, or if I rationalize the denominator, the square root of 21 divided by 7. That's my answer. Nah, the sine of A is equal to that number. I want to know what capital A was equal to. Well, unfortunately, this is not a y-coordinate you have memorized on your unit circle, so the best I can do for capital A is just say it's the arc sine of the square root of 21 over 7. Note that if you're doing the homework and you type your answer in like this, arc sine's assuming you're talking about radian, so if you wanted A in degrees, you'd have to multiply this by 180 over pi to convert it into degrees. It's also worth pointing out that when you use the law of sines to solve for an angle, that's the hard case, the ambiguous case, and you have to worry about, wait, is this really the answer, or is my angle obtuse and I need to do pi minus this angle measure? Well, the good news is if you come up to your picture here, just looking at A, we can tell that A is not an obtuse angle. So what that means is that it's just equal to the arcsine of the square root of 21 over 7. Let's collect all the information that we have. Given in the problem was that A equals 4 and that B is equal to 6, and that this, which is capital C because it's opposite little c, is 60 degrees. We first solved for little c using the law of cosines, and we figured out that little c was the square root of 28. That was done up here. We then solved for capital A using the law of sines. Turns out we could have solved for capital A using the law of cosines. I'm going to show you that in the next video. But at this point, we don't have that knowledge. We solved for capital A down here and figured out it was the arcsine of the square root of 21 over 7. However, since this is given in degrees here, and this is radians, what I'm going to do is I'm going to multiply this by 180 over pi so that this is now given in degree. All that's left to figure out is capital B. You have lots of options for capital B. One option would be to use the law of cosines to figure out this angle measure, but I haven't taught you how to use the law of cosines to figure out an angle measure yet. That'll be the next video. Another option would be to use the law of sines, much like you did here, to figure out capital B. A third option, which is probably the easiest option, is to recognize that the sum of the interior angles in any triangle has to be 180 degrees. So capital A plus capital B plus capital C must equal 180 degrees. So if I want capital B and I already know capital A and capital C, I could say capital B is 180 minus A minus C. C is 60 degrees and A is this mess. So I could say capital B is 120 degrees, the 180 minus the 60, minus this mess, the arcsine of the square root of 21 over 7 times 180 over pi. Note that here it was important that I converted this into degrees because all my other units are in degrees here. If I want to use this formula in degrees, this angle measure has to be in degrees. This is a perfectly acceptable answer for B. And now that we know capital B, we've solved this triangle and we're done with this example. I wanted to show you how to solve this triangle because there's a couple problems on the homework where you do this. But for what it's worth, if this were a test, I would probably have you solve for little c and then call this good. Right? If I'm trying to test your knowledge of the law of cosines, what I'm going to have you do is just one step, not figure out little c and then use that to figure out capital A and then use that to figure out capital B. Because if the student can't figure out this, you can't show me any of this stuff in here. There'll be a different test question where maybe you use the law of sines to figure out an angle measure. But if this is a law of cosines question on a test, you're just solving for one thing and then you're calling that good. You're not using that answer to solve for more things. Maybe that's a little bit comforting to hear.